Do you think all crocodiles are fierce water-dwelling predators? Forget that image. Meet Simosuchus, a prehistoric crocodile so strange it has been called the weirdest crocodyliform ever discovered. At just about 2.5 feet long, Simosuchus had a short snout, leaf-shaped teeth, and a completely terrestrial lifestyle. All of these features are the exact opposite of a typical crocodile. The discovery of Simosuchus didn't just add a quirky creature to the fossil record, it fundamentally changed our understanding of crocodile evolution, revealing that these ancient reptiles were far more diverse and adaptable than the image of unchanging aquatic predators suggests. For most people, the word crocodile conjures up the image of a massive, scaly predator lurking in rivers, its long snout and sharp teeth ready for an ambush. This view is reinforced by popular media and textbooks painting crocodiles as relentless survivors, ancient reptiles that haven't changed much over millions of years. While it's true that modern crocodilians trace their roots back to the late Cretaceous, the deeper fossil record reveals a surprising amount of diversity and experimentation among their ancient relatives. Simosuchus stands out as a clear example of this unexpected variety. Unlike the streamlined aquatic hunters we know today, Simosuchus looked and lived in ways that defy our expectations. Its skull was short and broad, about 4 inches wide and 3 inches tall in adults, giving it a bulldog-like appearance that's difficult to reconcile with the crocodilian stereotype. Instead of the long pointed jaws designed for catching prey in water, Simosuchus had a compact, almost comical face. Its teeth were leaf-shaped and finely serrated features, more suited for grinding plant material than slicing meat. When researchers first uncovered Simosuchus fossils in Madagascar's Mai-Varano Formation, they faced immediate challenges in classifying the animal. The initial discovery included a nearly complete skull lower jaw and much of the skeleton, providing an unusually detailed look at its anatomy. Early on, some paleontologists debated where it belonged, given its unusual body plan. Only after careful examination of its skull's unique features, known as autapomorphies, did scientists confirm that Simosuchus was indeed a crocodyliform. These autapomorphies, or distinct anatomical traits, set it apart from other reptiles and clarified its evolutionary relationships. The rest of Simosuchus's body reinforced its oddity. Its torso was short and robust, covered by a network of thick, bony plates called osteoderms that formed a suit of armor across its back, underside, and limbs. Unlike modern crocodiles, which have powerful tails for swimming, Simosuchus had a short, blunt tail and sturdy limbs adapted for walking on land. Its overall proportions, less than 1 meter long with a tank-like build, suggested a terrestrial lifestyle. The combination of a small, armored body and herbivorous teeth was unlike anything seen in living crocodilians. Such a mix of traits led to more questions than answers. Why did Simosuchus evolve such a different appearance and way of life? What environmental pressures or opportunities in Cretaceous Madagascar could have produced a crocodile that looked and behaved so differently from its modern relatives? The presence of so many unique features, including the retention of juvenile characteristics into adulthood, a phenomenon known as pedomorphosis, further complicated the evolutionary picture. Far from being an evolutionary outlier, Simosuchus highlights the broader range of forms that ancient crocodiliforms explored. Its discovery forced a re-evaluation of the idea that crocodiles are living fossils with little change over time. Instead, the fossil record, especially with finds like Simosuchus, reveals a family tree marked by adaptation and ecological diversity. This animal's anatomy not only challenged assumptions, but also opened new questions about the paths crocodilian evolution could take. Understanding what set Simosuchus apart required more than just noticing its odd proportions. Scientists needed to study every detail preserved in its fossilized bones to unravel how it lived and where it fit within the crocodilian lineage. The answers lay hidden in the intricate anatomy of its skeleton, waiting to be decoded. How do you prove that something isn't quite what it seems? The answer, at least for Simosuchus, lay hidden in the incredible details of its fossilized bones. When scientists first uncovered these ancient remains in Madagascar's Maevarano Formation, they immediately knew they had stumbled upon something extraordinary. The fossil specimens preserved with stunning clarity revealed 45 unique features in the skull alone, differences so distinct that they place Simosuchus in a category all its own. These features, known in paleontology as autapomorphies, gave researchers the tools to reconstruct not only Simosuchus's anatomy, but also hints about the life it lived, one that looked nothing like the carnivorous predators most people associate with crocodiles. The process of interpreting these fossils wasn't easy, though. Simosuchus challenged expectations every step of the way, starting with its teeth. Instead of the sharp conical teeth designed for gripping and tearing meat, typical of crocodilian diets, Simosuchus had teeth shaped like tiny serrated leaves. Their edges were highly complex, with multiple cusps or points on each tooth. These features made its diet clear. This was a crocodilian that shredded plant material, not animal flesh. Combined with its blunt snout and large upright skull, scientists quickly recognized that Simosuchus was unlike any crocodilian past or present. Yet these differences were so stark that early researchers questioned whether it could even be classified as a crocodilian at all. Its unusually short snout earned it the name Simosuchus, which means pug-nosed crocodile, but its appearance confused many paleontologists early on. Every aspect of Simosuchus's skeleton added another layer to the mystery. Its limbs were unusually robust, with thick bones built for strength, rather than the streamlined efficiency seen in modern crocodiles, which glide through water with ease. The short and tightly compact tail in particular stood out. It was far shorter relative to its body length than in any other known basal meso-eucrocodilians. This tail seemed unnecessary for swimming and instead hinted at a terrestrial plant-focused lifestyle. Adding to this image of a stout land-dwelling animal was its armor. Simosuchus' entire body was covered in osteoderms or bony plates, which acted like a suit of natural protection. These plates extended not just across its back, but down its underside and even onto its limbs. The armor was lightweight and porous in some areas, but robust where extra protection may have been needed, like over vital organs. These fossils came from the Maevarano Formation, a late Cretaceous geological site in Madagascar, which turned out to be a treasure trove of paleontological information. The completeness of the Simosuchus specimens was rare and invaluable, including fully intact skulls and much of the skeletal structure. This level of preservation allowed scientists to use advanced tools such as high-resolution CT scans to examine even the smallest details of the animal's anatomy. In its skull and lower jaw, researchers uncovered detailed pathways for nerves and blood vessels, a level of anatomical insight rarely possible with fossils. These pathways help confirm how Simosuchus relied on its broad leaf-shaped teeth and provided further proof of its herbivorous diet. Together, these clues painted a vivid picture of Simosuchus's place in its environment, one very different from the predators lurking in rivers today. Its body was designed for stability on land, where strong limbs carried it through the dense vegetation of Madagascar's late Cretaceous landscapes. And in these unique adaptations, scientists began to see key insights into its evolution. The puzzle pieces fell into place, and it became clear that Simosuchus defied the common perception of crocodiles as unchanging carnivores. Not only was this animal small and pug-nosed, but it also grazed on plants and avoided aquatic habitats altogether. Simosuchus proved that crocodilian evolution wasn't a single straight line. Instead, it was full of experiments, adaptations, and unexpected branches like this herbivorous, armored little creature. But these discoveries raised new questions as well. How did its isolated home on Madagascar shape its evolution? And why did other crocodilian lines remain tied to water while Simosuchus boldly adapted to land? These questions bring us closer to understanding the adaptability of crocodilians and just how far these ancient reptiles could push the boundaries of their group's evolution. Imagine encountering something that looks like a small armored crocodile, only to realize it doesn't swim, doesn't stalk prey, and most astonishingly, doesn't even eat meat. That's Simosuchus. Its leaf-shaped, multicuspid teeth provide convincing evidence that it consumed plants exclusively, a stark contrast to the sharp conical teeth typical of meat-eating crocodilians we recognize today. These teeth, with their complex ridges and multiple cusps, were perfectly designed to shred and mash vegetation, making Simosuchus a true anomaly in a lineage dominated by carnivores. But this dietary divergence raises an important question. Why would a crocodilian evolve to become a vegetarian? The answer lies not just in its anatomy, but in the environment it called home. Simosuchus's body was built for life on solid ground, not the water. Its short, stubby tail, the shortest relative to body size of any known basal mesoeucrocodilian, offered no advantage for propulsion in an aquatic setting. Instead, it suggests a reduced need for swimming, as this animal didn't depend on rivers or swamps for survival. Adding to this terrestrial adaptation were its robust limbs. Unlike the elongated paddle, like limbs of modern crocodiles, Simosuchus had sturdy, muscular legs structured for stability and mobility on land. Scientists have even speculated that this limb design could point to possible burrowing behavior, though this idea remains debated. If true, it might mean Simosuchus created shelters for protection or to escape the heat of its semi-arid environment, using its large armor-plated body to block the entrance from predators. Whether it burrowed or simply relied on its tough build to fend off threats, one thing is certain: it was highly specialized for a herbivorous terrestrial lifestyle. To understand why Simosuchus evolved this way, we need to consider its surroundings. During the Late Cretaceous, Madagascar was an isolated island separated from the rest of Gondwana for tens of millions of years. This isolation led to the development of a unique ecosystem full of species found nowhere else on Earth. Madagascar's environment at the time was semi-arid, with scattered floodplains that supported patches of vegetation. For a small plant-eating reptile like Simosuchus, this ecosystem provided both food and safety, but it also demanded adaptations to dry land. Over time, Simosuchus became perfectly suited to its niche, thriving as a grazer in this one-of-a-kind island environment. Interestingly, Simosuchus wasn't the only animal to bear evidence of this unusual evolutionary path. In the Kalamadu Formation of present-day southern India, paleontologists discovered a tooth nearly identical to those of Simosuchus. This discovery suggests a close relative of Simosuchus once lived there, reinforcing the ancient connection between Madagascar and India when the two were part of the same landmass. That shared history highlights how geographic events like the breakup of Gondwana didn't just shape continents, they shaped life itself. Species like Simosuchus reveal how isolation and local conditions drove evolution in remarkable directions, creating animals that defy expectations. And if avoidance of water seems unusual for a crocodile, its armor made Simosuchus even more distinct. Tightly interlocked osteoderms covered not just its back, but also its tail and limbs, forming a true suit of armor. These bony plates served multiple purposes, shielding it from predators and reinforcing the fact that Simosuchus was built to spend its days foraging in open environments, not slipping into murky rivers. Even its heavily armored limbs were unusual. Their coverage hints at an extra layer of protection for living full-time on land. Together, its strong legs, short snout, and dense body paint, a picture of an animal shaped entirely by its environment, a crocodilian that had little in common with its sleek aquatic relatives. These adaptations reveal just how versatile crocodilians were in the distant past. Instead of sticking to the predatory aquatic niche we associate with them, some broke the mold entirely, taking to land and exploring entirely new diets. Simosuchus is an outstanding example showing that crocodilians diversified into ecological roles we rarely imagine for them today. But what does this say about crocodilian evolution, or even evolution as a whole? To find the answer, we need to step back and explore what this discovery means for the broader story of life on Earth. The discovery of Simosuchus provides a clear example of how evolution can lead to unexpected outcomes, even in groups as familiar as crocodyliforms. By revealing a lineage that adapted to life on land and a plant-based diet, Simosuchus directly challenges the idea that crocodilians have always been aquatic predators. Its fossils highlight the broader evolutionary pattern among ancient crocodiliforms, where repeated transitions between aquatic and terrestrial lifestyles and even herbivory occurred across different lineages. This diversity is a reminder that crocodilians once explored ecological roles ranging from tunnel diggers to giant marine predators. With every new fossil, our view of their evolutionary history expands. The existence of similar herbivorous Notosuchians in Gondwana suggests that more discoveries, just as surprising as Simosuchus, may still be waiting to be uncovered.